Welcome, lovers. So the topic we want to consider is on binomial expansion theorem. So from my previous video, so we've discussed about factorial and combination and permutation, which we are going to apply here. So on binomial expansion theorem, then that is we have a plus b raised to power of n. We want to expand this using binomial expansion theorem. So the coefficients of each term, we are using combination to determine the coefficient of each term, that is n combination 0. So a raised to power, then a will take the first term here, a will take power of n, then b will take power of 0, b raised to power 0, then n, the next coefficient will be n combination 1. A, the power of a will be decreasing by 1, then power of b will be increasing. So plus n combination 2, a raised to power n minus 2, b raised to power 2, plus n combination 3, a raised to power n minus 3, b raised to power 3, plus. So when you continue, you will definitely arrive at b raised to power of n. That is, you are going to arrive at n combination n, then b raised to power of n. This will be the last term and the coefficient here. Now, the next thing is to simplify. So the n combination 0 equals n factorial divided by n minus 0 factorial. Then 0 factorial. Don't forget the formula for solving combination. So that is n combination r equals n factorial divided by n minus r factorial, then r factorial. In this case, r equals to 0. Then we have a raised to power n, b raised to power 0 is 1. That is indices. N number to power of 0 other than 0 is said to be 1. Then we have plus n factorial divided by n minus 1 factorial, 1 factorial. Then a raised to power n minus 1, b raised to power 1. Then plus n factorial divided by n minus 2 factorial, 2 factorial. A raised to power n minus 2, b raised to power 2. When you continue, so because of time, so when you continue, you are going to arrive at n factorial divided by n minus n factorial, then n factorial, then multiplied by b raised to power n. In this case, b will be raised to power of n, while a will be raised to power of 0. So that is, we have a raised to power 0, b raised to power of n. So we have to simplify further. So n minus 0 will give us n. That is n factorial. N factorial, we cancel n factorial. 0 factorial is 1. So therefore, here we will be left with a raised to power n. So, but in this case, we are going to expand this. So don't forget, when I was discussing on factorial, so that is n factorial, you continue to be decreasing, that is the value of n will be decreasing by 1. Each term, the subsequent term will be decreasing by 1. So here we'll be having n, then the next will be n minus 1. Because we have n minus 1 here, we are going to stop and put factorial there. Then divided by n minus 1 factorial, then 1 factorial. This will cancel this. Then we have a raised to power n minus 1, b raised to power 1, plus n. Then we are going to expand this one to n minus 2. That is n into n minus 1, then n minus 2. Then we put factorial there because there are other numbers. But because we are having n minus 2 factorial here, we stop. Then divided by n minus 2 factorial, 2 factorial. A raised to power n minus 2, b raised to power 2, plus. Then we have the last term now. N factorial divided by n minus n will give us 0 factorial, then n factorial, b raised to power n. This and this will cancel out. So in this case, this will cancel this. So therefore, the formula now for solving question of binomial expansion theorem, we have a raised to power n plus n into a raised to power n minus 1, b raised to power 1, plus n into n minus 1, a raised to power n minus 2, b raised to power 2, divided by 2 factorial here, then plus. So then we have the last term to be b raised to power of n. We can expand this one as long as possible. So you can extend this one. That is, if you want to write the next term here, you can do that. But to save time, so this is the result. When this is expanded, you are going to get this. That is a plus b raised to power of n equals to this. This is binomial expansion theorem, which we are going to use in nearest future in solving question. Thank you.